energy could turn the Earth's ozone layer into a radioactive inferno.
Even a gamma ray burst that's thousands of light years away could deplete the ozone layer to roughly half of its current level. Now, that won't kill all of the species, but it could lead to what we call a mass extinction, where a good fraction of all living species die rather suddenly.
So the burning question is, will the death of WR-104 really trigger a gamma ray burst? Scientists just don't know. The mandatory requirement for a star to produce a lethal gamma ray burst is high horsepower rotation. All stars rotate on their axes. Some massive stars can spin very fast.
So the rotating star, the rotational energy is part of what produces the gamma ray burst.
If you can put the brakes on, if you can take that rapidly spinning star and slow it down before it gets to that stage, you've defused that bomb.
Based on mounting scientific evidence, it appears the universe itself is applying another set of brakes to its stars. It's called metallicity. Stars are primarily made of hydrogen and helium. But heavier, more complex elements are created every time a star explodes. Elements like carbon, nitrogen, and oxygen that then become the raw materials for the next generation of stars. So a star born today has more heavy elements, also known as a higher metallicity, than a star born earlier in the history of the universe.
When a massive star has a lot of heavy elements in it, it tends to lose a lot of its mass through winds. And if it loses a lot of its mass, it also loses a lot of its rotation. And it ends up rotating too slowly to form a GRB.
So something is happening to the Wolf-Rayet stars today that's going up there and defusing all the bombs. So they're still blowing up as supernovae, but far, far fewer of them are taking that supernova to the next step as a gamma ray burst.
Could these breaks slow WR-104 enough to render it harmless to the Earth? Many astronomers believe so. But what if they're wrong? At 8,000 light years away, is Earth really in the danger zone? When the Death Star, called WR-104, finally explodes, it has the potential to unleash a deadly gamma ray burst directly at Earth. It's believed the star is roughly 8,000 light years away from us. Is this close enough for a gamma ray burst to do damage to our planet?
And being 5,000 to 8,000 light years away, it's in the danger zone. Earth's life might take a bad hit when that radiation reaches us.
If it was another 2 or 3 times further away, we'd probably be okay. And if it was 2 or 3 times closer, we'd really be shaking in our boots. But it's just at the edge of its range where one would expect, well, you know, it might do something, but it's probably not going to roast us all in our sleep.
So perhaps once every billion years or so, there's a gamma ray burst that's sufficiently close and sufficiently well pointing toward us that we need to worry.
Death stars of all sizes populate the universe. But stars are not the only entities capable of such violence. The universe is also home to death galaxies, like 3C321, also known as the Death Star Galaxy.
3C321 is a galaxy with a giant black hole in the middle, millions of times the mass of our sun.
Just outside the black hole's edge, The chaotic churning of magnetic fields and gravitational pull has ignited a high-energy particle jet. These jets are not uncommon, but this one is delivering a beating to its nearest neighbor.
The case of 3C321 is very interesting because there happens to be another galaxy 20,000 light years away. The stars in that galaxy are being blasted by the energetic particles and radiation from one of these jets.
X-ray astronomer Dan Evans has been tracking the Death Star galaxy and its violent behavior from the Chandra X-ray Satellite Control Center outside Boston.
So we see black holes do kind of strange things, but only a very small fraction emit these powerful jets of particles. And a fraction even smaller, such as the 3C321 galaxy, the Death Star galaxy, smack into other companion galaxies. So that's incredibly rare.
The companion galaxy is across the galactic street, 20,000 light years distant. The massive energy beam, even larger than a gamma-ray burst from a dying star, is firing non-stop with a seemingly limitless energy supply.
So what we're looking at here is the best terrestrial analogy for the Death Star galaxy, 3C321. A jet is racing out of the black hole, close to the speed of light, and it's actually normally would propagate up to about 1 million light years away. But in the special case of 3C321, that jet is slamming into the side of a companion galaxy. And in doing so, it's becoming disrupted and distorted and bent away. And that's wreaking all sorts of havoc for that companion galaxy.
Much like the building is deflecting the water jet, the planets and stars in the victimized galaxy are deflecting most of the attacking particles.
So this jet is actually a massive beam of energy and particles. And these particles have been superheated such that they form a plasma.
Plasma is a mix of super-hot, charged electrons and ions funneled into the jet by the black hole's immense magnetic field.
So jets that race out of black holes are actually incredibly energetic. And in fact, they can accelerate particles such that they emit light, maybe even up to gamma rays. So these rays are incredibly powerful.
And very long-lasting. Some estimates say the energy jet from the Death Star galaxy has been firing for nearly 2 million years. For its fuel, 3C321 simply devoured an entire galaxy.
It's got a lot of fuel. What we actually think is happening here is that there's been a previous merger. So another galaxy has fallen in to the main galaxy. We can see this beautiful dust lane, which implies that the galaxy has been shredded already. And so that act of shredding drives mass down onto the black hole.
After consuming another galaxy's provision of plasma particles, the Death Star galaxy has to somehow energize the particles into a jet. Black holes have powerful magnetic fields and super-fast spin rates, a combination that somehow ignites the particle jet. Scientists believe the reason the jets fire in one direction has to do with all the dust and gas circling the black hole.
In the case of an active galaxy like 3C321, which has a supermassive black hole in the center, you'll often have a donut or torus of material surrounding it. In that case, highly energetic particles near the black hole can't emerge from that region through the donut along the plane of the galaxy. They can only emerge